Now let's look at the third example problem in this topic. It's called the second order statistics. So you should read the problem on code forces first before go on with the video. So the link to the problem is available in the description, in the video description, or if you are looking at the slides, the link is also on the slide. So the problem asks us to determine, to find the second smallest number that appears in a list of numbers. So the first line of the input gives have one integer which tells us how many numbers there are, and then the second line provides those numbers. So these are the two different sample inputs. First one with the 4 numbers, second one with 5. So for the first one, the answer is 1 because the smallest number that appears is -4. Then the second smallest is 1. And in this example, the smallest number is 1. 1 actually appears 3 times. But the problem, the wording of this problem is we don't want the answer to be 1. It's not that if we sort all these numbers from small to large, what is the second? In that case, the answer is 1. Here, we literally want the second number, the second smallest number that appears. So 1 is the first smallest number, and 2 is the second. So the answer to this is 2. So you should think about how you would solve this problem. So there are many ways to solve this problem, and a lot of the more succinct ways succinct in the sense that the code is shorter, will use built-in data structures and functions that Python provide. But here we will first try to do it without using any of the special data structures. So we just use a list, and then we just enumerate through them, because it's important to understand how to do these basic operations. So before we tackle this problem, let's first try to compute the smallest number in a list. So this will be easier. Um, so I want to ask you to reflect on how you will find the smallest number in a list. And I guess the first thing is, if this is a sample input, what is the smallest number? You can probably tell me in a glance and tell me, oh, it's -9. But I want you to think about, well, how did you find it out? And what if maybe your answer is, well, I glanced it and the answer just popped into my head. But if you have a lot more numbers, let's say you have pages and pages of numbers, and you need to find out what is the smallest, then you can't just glance everything and then things just pop out. So you need some strategy to actually do it. So I think what you are likely to do is you will start looking at the numbers, and then mentally you will keep track of which one is the smallest so far. So and if you see someone that's even smaller than the smallest so far, then you will use that to replace your current. You will remember that number. So in some sense, what we are doing using computer code is the same strategy, and we'll be looking at this each of this number one at a time, and at the same time we remember what is the current smallest number. So this is just before we show the code, let's just reflect. This is what we do. So suppose we know these are the input, but we're not able to see the rest of it yet. So we see 1, so 1 is the current smallest, and then we see 3, so 1 is small, still the current smallest number. So we just remember 1 on the side, and we see 4, so 1 is still smallest. We see -5. Now -5 is smaller than 1, so now we will remember -5. And we see 10, we still remember -5. We see -9. Because this one is smaller than -5, we remember -9. And then we see 1, 1 is greater than -9, so we'll just keep -9. And since we reach the end, -9 is the smallest. So this is how one can implement the smallest. Now, yeah, so this is the code for doing that. So we reading yeah, so this is So I wrote this code which will just take some input. So you write one line of input, which will be the number that you want to put in, and this code will find the smallest. So it first read all the input in, and then after we do the map, we convert that into a list. So if we don't do this, if we don't use this list, this map thing will give us something called an iterable. So we can use this thing in a for loop, but we can't access it like a list. Um, so I think I will actually illustrate this difference a little bit later. So then we assume that there's at least one element. So we first just say the first element is the smallest, and then we just go through every element in the list. And if we find something that's smaller than the current smallest, we will remember that. So then we'll set our current smallest to be x, and in the end we'll just print out the smallest number. So I guess this is the one thing of a computational thinking is these variables smallest, its value is going to be continuously changing, but there is a well-defined semantic for this value. So that is, these store the smallest number we have seen so far. So then we will look at the one by one, and then sometime we will update it, sometime we will not. So it's these procedure aspect I believe maybe hard for beginners to sort of to master. Okay, so that's how you find the minimum value. Now, how do you find both the smallest value and the second smallest value? So since we are trying to find two, then that means we need to remember two things. One for smallest, the other for second smallest. So let's say these are the cells that we store that, or basically these are two variables. So then for each new value, each new number we see, what do we do? What do we need to update this so that they will still contain the correct smallest value and the second smallest? So what we do will depend on how x compare with these two numbers. And there are 5 cases. So if we draw the number line, we have smallest, second smallest, and then there'll be 5 cases. So the first is x is less than smallest. The second is x equals smallest. Then x may be between smallest and second smallest, or x may be equal the second smallest, or x may be greater than second smallest. So again, mentally draw a number line. I guess if smallest equals the second smallest, then there will be 3 states. So then one of them is no longer possible, and this x equals and its smallest and x equals second smallest will hold at the same time. So we can view the middle 3 will merge into one option. So the question is, what do we need to do to update these variables? So I encourage you to just think about it. So I'm going to stop here for this segment, and we're going to show the code to do this and explain what they are doing for these cases.